Good morning, class. Welcome to today's lesson on problem solving. This is for Tech Math, lesson 1.3. In problem solving, we are going to take a look at a variety of word problems. There's a lot of different word problems involved. And as we take a look at these word problems, we're obviously going to need to filter through the information we need and toss the stuff that doesn't really matter too much. You've probably done this experience quite a few times in your life already. In fact, you probably problem solve on a daily basis. And it's no wonder that this chapter itself, or I should say this section itself, is about 12 to 13 pages long. So that being said, we will be splitting the assignment into two parts, but it's all practice. So we're going to practice through quite a few different examples of problem solving. So as we look at problem solving and what it entails, we can look to Mr. George Polya. He was a mathematician who taught at Stanford University. And he kind of came up with this method, these 4 different steps to solving the problem. If you've done the reading, as you should have for lesson 1.3, you'll have a little background information on this. If not, the table on page 20 is a great resource for you to take a look at to help you get through these problems. First things first, we have to understand what's being asked in the problem and make a diagram if necessary. A few of these will need diagrams. Eliminate any unnecessary information and determine if you have all the information needed to solve this problem. Once you understand the problem, then devise a plan to solve that problem. Carry out that plan and check your results. That last step, checking results, is so important. You need to check to see, does this actually make sense? Is this answering the question? Is there an alternative method? So looking through these different steps and stages as you go through all the different problems we're going to work out, it's going to help you be successful in solving problems. Let's take a look at a couple examples. Here's one you may have heard of before. Example number 1, as I was going to St. Ives, I met a man with 7 wives. Every wife had 7 sacks. Every sack had 7 cats. Every cat had 7 kids. I think it's supposed to be kits. Kits, cats, sacks, wives. How many were going to St. Ives? Not including the narrator. Take a moment, pause the video, and solve this problem. Now, theoretically, you would look at this problem and say, okay, so I'm going to St. Ives. I met a man. He's got 7 wives. Okay, so that's 7. Every wife had 7 sacks, so I take 7 times 7. Every sack had 7 cats, 7 times 7. Every cat had 7 kittens, I guess. So that's another times 7, and then 7, okay, do all the math. So bam, that's easy peasy. 2,801, not including the man, we're going to St. Ives. However, I kind of read this riddle a little bit differently. For me, I would say actually only 1, because I was going to St. Ives. The man, they're probably leaving St. Ives. They're going somewhere else because I met them on the road. Now, you could venture and say, well, we're all going to St. Ives. I just happen to be walking in the same road with them. But anyways, you see the idea here. You figured out, hopefully, that you were supposed to multiply to get to that point. Okay, example number 2. A boatman must transport a wolf, a goat, and a bundle of herbs across a river. If the boat is so small he can carry only one of them at a time, how can he make the crossing so that the wolf will not devour the goat and the goat will not eat the herbs? Clue: the boatman must make multiple round trips. That is definitely a clue. Pause the video. See if you can solve the problem. Now, for this example, you're going to probably want to draw a very simple diagram that has the shore and then has the island, and you've got your 3 characters. So you're probably going to draw a couple of lines going across the river to get back and forth and back and forth. So as I mentioned, you drew your lines, and hopefully you're able to come up with the number of times that the wolf, the goat, and the bundle of herbs would have to be carried across the river, and the answer is going to be 7 trips. If you're not 100% sure on how you get to 7, go ahead and use your resources, see if you can figure that out. Number 3, many buses provided by Cherry Transportation operate between John Fitzgerald Kennedy Airport and downtown Manhattan, 25 miles away. One particular bus makes 10 round trips per day, carrying an average of 42 passengers per trip. The fare each way is $13. What are the receipts from one day's operation for this particular bus? Pause the video, solve the problem. Well, in order to solve this, we'd have to figure out information we need. Well, we know we can make about 10 round trips per day, carrying about 42 passengers per trip. So that's about 420 price points. We take that times 13, and we're going to get somewhere in the $10,920 range. So that's our third example. Again, if you're not sure on any of these examples, please do ask. If you write them out, they're going to work a lot smoother. On to example 4. Instructions on a bottle of insecticide indicate 1.5 ounces of insecticide should be mixed with 5 gallons of water. Dave wishes to spray his garden. How much insecticide should he mix with 8 gallons of water to get the proper strength solution? Pause the video. So in looking at this, what we can do is calculate out, and I would use just a simple 2 fractions. 1.5 ounces is to 5 gallons as X ounces is to 8 gallons. You can do a simple cross multiply and divide, and hopefully you got 2.4 ounces. Example number 5, a magic square is a square array of numbers such that the numbers in all the rows, columns, and diagonals have the same sum. Use the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9 to construct a magic square. So again, magic square looks like this. Pause the video, see if you can make a magic square. All right, hopefully you're able to figure that part out. In making a magic square, there's a couple different ways to do it. There's always the kind of guess and check method where you can just drop some numbers in. But here's one example of a magic square where each of the rows, each of the columns, and each of the diagonals will equal to 15. So this is just a handful of examples. And if you think back and go all the way back to that initial piece, I know this is going to be slow. I apologize. I should have put this slide at the end. But here, these guidelines for solving the problem, that's what's going to be key. So following these guidelines, understand the problem. What are they asking for? Figuring out some kind of plan to solve it. Carry out the plan and check your results. It might be messy. You might wind up having to do some erasing. You might wind up having to go down one path and realize, oh, that's the wrong path. That's okay. That's okay. It's all part of learning. So that being said, since there are quite a few problems we're going to work through, we're going to split this homework into 2 parts, part 1 and part 2. So part 1 is on pages 26 to 29. You're doing 2 through 34 even. And then part 2 will be due the next day, and that is number 36 to 62 even. So if you have any questions on these 2 parts, please ask. Otherwise, best of luck. Get out there and solve some problems.